Given that fx equals this, gx equal this, and hx equal this expression, and we have to find the formula for this composite function. Yes, this type of function is known as composite function. So first we will determine g of h of x. Okay, so what is g of h of x? So what we will do, we will substitute the value of hx in place of x. Okay, so we just replace x by hx and we obtain g of hx equals 1 by hx, because gx is defined as 1 by x, so we just replace this. Okay, now we know hx equals this one, therefore directly substituting the value we obtain g of hx equals 1 by x square minus 1. Now we have to determine f of g of hx. Can you do this? It's simple. We just have to replace the x with this expression the same way as we have finished this one. Yes, so f of g of hx, this will be, let's say this equals y. Okay, so how f x is defined? Fx is x by x minus 1, therefore if we assume this as y, f of y, we know from the definition this is y by y minus 1. Now what we assume as y? Our y equals g of hx, therefore substituting the value of y, we obtain g of hx. Similarly here, g of hx minus of 1. Now our g of hx, it is from here, so it's simple, just substituting the value once again here. We have g of hx equal 1 by x square minus 1, g of hx 1 by x square minus 1. Now if we simplify this, since we do not have enough space here, let's write down here. So if we simplify this, we obtain 1 by x square minus 1, then here 1 minus x square minus 1, and this x square minus 1 will go in the numerator, this x square minus 1 and this x square minus 1 will get cancelled out. Yes, and in the denominator if we simplify, we obtain 1, it is 2 minus x square. Yeah, so we obtain this composite function f g h x, which can also be written in this way as 1 by 2 minus x square. Okay, let me just box this with a different color. So this is our answer. Now we have another additional question here, that we have to state the domain of this composition. Yes, so what is the domain of definition? So what is the meaning of this, that we have to state the domain of this composition? So we have to exclude those points that makes the function undefined. Yes, we have our function as 1 by 2 minus x square. Now the domain of this function, of this composite function, it means we have to exclude all those values of x for which these functions became undefined. That is like 1 by 0 or 1 by infinity or infinity by infinity or 0 by 0. These are the 4 undefined form. Yes, so we have to check out that this function should not attain any of these such values, or whatever you can say. These are not values, these are undefined thing. So can you say that at which values of x these things occurring? Now observe that this is not possible in this case because in the numerator we already have 1. This is also not possible. Yes, so these two things gets excluded, remains this one and this one. Now from here this is also not possible because this is not in that form, right? So left only this one. And when this thing will occur, it will occur when x square equals 2, and this implies that x equals plus minus square root 2. Therefore, we have to exclude this value. X square should not be equal to, okay? Otherwise, this function will be undefined. Therefore, the domain of definition of this function it can be written in this way: 2 minus x square, and the domain of definition we should exclude x is not equal plus minus square root of 2, okay? Or you can say that x square is not equal to. Why? Because otherwise the function will become in this form. It is in undefined form. It is obtaining. Yes? Okay. In each part, classify the function as even, odd, or neither. Now, what is the definition of an even function and odd function? Let's say f is a function. We will call this as an even function if we can write the function in this way: f of minus of x equals fx. This is the definition of even function. For example, let's say fx equals x square. Now, f of minus x, what we obtain? Minus x whole square. This equals x square. Therefore, we can write f of minus x as f of x. Yes? So, this is an even function, right? Similarly, let's say fx equals x. f of minus x equals minus of x. We obtain here this as minus of fx. f of minus of x equals minus of fx. Now, function of this type is called odd function. Okay? When we have f of minus of x equals minus of fx, this type of function is known as odd function. Okay? So, f of x equals x, this is an odd function. f of x equals x squared, this is an even function. Or else you can also prove or show it that, or you can even try it in your home, that any function of odd power, say 3 or x5 or x7, these are all odd function. Okay, you can check it by yourself. And any function of this type, even power, x to the power 4, x to the power 6, 8, these are all even function. Okay, this is odd function, this is even function. Okay, so you have to verify this, that which one of this is either odd, even, or neither. Function can be even, odd, or neither. So let's check the first one. Let's take some different color. We have a, let's take fx equals x square sine x. Now from the definition, let's replace x by minus x. Then here we obtain minus of x whole square sine of minus of x. Now minus of x whole square, this gives us x square, and we know sine of minus of x equal minus sine x, right? Yes. Therefore, from here we obtain this as minus of sine x. This gives us minus x square sine x. This equals minus of fx. Therefore, this is an odd function. So we write the answer odd function. Okay. Similarly, problem B. Let's take fx equals. Would you like to try this by yourself? Try it. Pause the video. Try it by yourself and come and check. Meanwhile, I am finishing this. f of minus of x replacing x by minus of x, we can write this in this form. Now we know this equals minus of sine x whole square equals sine square x. Yes, and we obtain this as fx. F of minus x equals fx we obtain. Yes, so this is an even function. Yes, this is an even function from the definition. Similarly, problem C, let's take fx equals x plus x square. Replace x by minus x, very simple. Yes, plus we just have to replace x by minus of x, that's all, and then simplify and then see what is obtaining. Okay, minus of x plus x square. Now see here, we cannot write this as in this form, right? Because here the function is getting completely changed. The symbol is not changing only, everything is getting changed. So the function is getting completely changed. So this is neither even, neither odd. Yes, so this is neither. Yeah, the final problem D, let's take same procedure. Sin x, tan x. My handwriting is little bit fuzzy, I think you guys still can understand. So f of minus x, we have sine of minus x, tan of minus x. Now we know minus sine of minus x is minus sine x. Yes, and tan of minus x is minus tan x. Multiplying, minus minus multiply will be plus, and ultimately we obtain sine x tan x, that is, this is fx again. So f of minus of x equals fx. This is again an even function. Okay, we have 4 functions here. We have to find the inverse of each of this function. Okay, before proceeding further, let me just give you a brief idea that what is an inverse function. Let's say fx is a function. Okay, we will say g is an inverse of f if g of fx equals x. Okay, whenever these things occur, actually this also need to have. So whenever we have these two condition is satisfying, we will say f and g are inverse to each other. Okay, and the definition of inverse is actually both sides. Say for example, if this condition is satisfying but this one is not satisfying, then we will not say that g is an inverse of f. Okay, in that case we will say g is a left inverse of f. So we will know that in it is a bit of advanced mathematics, but for the time being, whenever we will say that inverse, it means that both conditions should satisfy. Okay, so we have to determine the g in all of this case. Now how to solve this kind of problem? So let's start with this one. We have fx equal 8x cube minus 1. So we need to determine its inverse. The procedure of solving this is, we will assume fx equals y equals 8x cube minus 1. Just look into it, how I am solving this. We will convert everything into the function of y. Okay, simplifying, we obtain this. So now we took the cube root. So now observe that everything has transformed into a function of y. Yes, so we can say, let's say this as gy. So the inverse of f, that is, which is denoted by this symbol, is this. So we can say that f inverse of x equals half of x plus 1 cube root. Okay, this is the inverse of this function. Similarly, we can solve problem B. Same way, we will assume fx equal y implies, and then we will see that if it can be transformed into a function of y, everything will be in function of y, and in the left side we have only x. We need only x. Okay, only then whatever will come at the right hand side, we will say that as an inverse of f. So if we solve this, it is a quadratic equation. Now observe that if we solve this, we will get 2 root, right? 2 plus minus b square minus 4ac. We have our b as minus 2, that is 2 whole square minus 4 in times 1 minus y by 2. Simplifying, we obtain this expression. Okay, 1 minus 1 plus y. Now here it is not possible to mention this as a function. Okay, this expression is not a function. Can you tell me why? Because from the definition of function, a function can take at most a single value. The output is a single value. Okay, output cannot be multiple valued. For example, fx equals plus minus x. This is not a function, because for x equal 1, the output is plus minus 1, right? For x equal 2, the output is plus minus 2. So this is not a function actually. This is not a function. A function output should be unique. At a time, there should be only one value. But in this case, we have two values, right? One plus square root of y and another is 1 minus square root of y. So this cannot be a function. So in this case, it is not possible to obtain the inverse. So inverse does not exist. Let's work upon on problem C. We have given fx equals ex whole square plus 1 equals e. E here is exponential. Okay. So similarly, let's assume this as y minus 1 equals exponential of 2x. Now how to evaluate this exponential? Taking log to the base e to both sides, we can eliminate this exponential. Yes, it will be 2 to the power 2x, sorry, it will be 2x. Log base e can be written as ln. Okay, it is the short form of writing log to the base e. Simplifying, you obtain x equals half of ln y minus 1. X equals half ln y minus 1. Now whenever we are writing as a log, we need to take a modulus. Okay, otherwise log function may be undefined. So the mathematical way of writing this expression is this one. Okay, this is the correct one. Okay, you should not write in this way, because we need a mod, otherwise log function becomes undefined. So we obtain our inverse function in this case as, you can write this as f inverse of x equals half of ln modulus of x minus 1. Okay. The last problem, we have fx equals x plus 2 by x minus 1. Let's assume this as y, x plus 2 upon x minus 1. We just have to simplify this. I think you can do this. Try this by yourself. Pause the video and then come back and check your answer. Okay, xy minus y equals x plus 2. We will do some sort of simplification. There is nothing to misunderstand here. Everything is simple. I am just doing the simplification. You take a pen and paper and try it by yourself. So in this case, we obtain the inverse function as x plus 2 upon x minus 1. And the domain of definition in this case, x should not be equal 1. Okay. As we have seen earlier, what is the domain of definition? Okay. Given that fx, limiting value of fx at the point A is 2, gx is minus 4 and hx equals 0, we have to determine the limiting value of all this function. Okay. So I will not do all of this. Better you should also try by yourself. I will do some typical one so that you guys can understand how to solve this. Okay. So let's start with the problem A. I will do problem A, problem F, then problem D and problem E. Okay. Let's do this for you guys. Try B and C. Yes. Okay. Let's start with problem A. We have to determine the limit x tends to a fx plus 2 gx. Okay. Now we can use this property. We can write this in this way. Yes. We can insert the limit. Since both the limit exist, we can do this. Okay. Otherwise, we cannot do this. Let me write it down here. This is possible because both the limit exist. This one and just a little bit of knowledge on mathematical analysis. So limit x tends to a fx is given as 2. Limit x tends to a gx is given as minus 4. 2 minus 8 equals minus 6. Okay. It is pretty simple. Nothing difficult here. Let's do problem D. Limit x tends to a gx. Again, since this limit exists, we can insert the limit inside the whole square. This is possible because this. Okay. Now we know limit x tends to a gx has given minus 4. So minus 4 whole square is 16. Problem E. We have limit x tends to a 6 plus fx cube. Same strategy, or I would say rather same formula or theorem basically, that since the limit exists, we can insert the limit. Whenever the limit exists, let me just tell you this thing, that whenever limit exists, we can insert the limit. Okay, it is called the limit operation. Okay, either it be a square root, cube root, whole square, whole cube, multiplication, addition, division, whatever. If the limit exists, then we can do this operation. We have here limit x tends to fx equals 2. This means cube root of 8. Therefore, answer is 2. Okay. Final one. Limit x tends to a 2 upon gx. Since the limit exists, and here there is a story actually. Here there is a story exists, and that is the limit exists since gx is in the denominator. The limit exists, and on top of that it is not equal to 0. Okay, you should have to remember this. In the case of denominator, if the denominator is getting 0, then we cannot do this thing. Okay, the limit exists plus the denominator, I mean the limiting value is not 0. The limiting value here is minus 4, right? Only for that reason we can insert the limit in the denominator. Okay, did you understand what I am saying? Let's say if limiting value of gx at a is 0, then we cannot do this next step. Okay, since the limiting value here is given -4, which is not equal to 0, because of that we can insert the limit in the denominator like this. Okay, let me just remove this. So we obtain here -4, and simplifying we obtain -12. So I hope this part is clear now. If you have any doubt, let me know. I will help you to understand. Okay, given a function which is defined in this way, say for fx, when x is less than equal 3, we have one definition, and when x is greater than 3, we have another definition. Okay, this type of function is called as piecewise continuous function. Maybe we'll learn this later. This type of function is named as piecewise continuous function. Okay, why it is piecewise? Because it has some discontinuity at some point. Okay, so since this is not our topic of discussion right now, so we will not go into the details. Just for your knowledge, I will let you know. It's okay if you have any problem. Okay, just let me know. Okay, so coming to this problem, so we have to determine its left hand limit, right hand limit, and its total limit, the actual value of the limit. So let me just tell you one thing. We will say, just before I have discussed this problem, that existence of a limit. So when we say a limit exists, okay, when we say, we will say, let's, for this problem, we will say that the limit exists, this value exists only if the left hand limit and the right hand limit both exist and are equal. The left hand limit and the right hand limit both should exist and are equal. Only then we will say that this exists. Okay, only then the questions of existence of a limit comes actually. Let's say if this exists and this exists, but the values are not equal, then we will say that this limit does not exist. Okay, let's say this exists and this does not exist. Same answer will be same. Okay, so let's now solve this. First, we have to determine the left hand limit. So what is the left hand limit of this function x tends to 3 minus of fx? Now see, when x is less than 3, x tends to 3 minus means x is less than 3. It is left hand limit. We are on the left hand side of 3, right? This is 3. We are on the left hand side. That's why it is 3 minus means less than 3. Okay, everything here is 3 minus and everything here is 3 plus. So this is the right hand side, this is the left hand side. So when x is less than 3, that is, we should follow this definition. The values of fx will be x minus 1. Okay, now we will straightforward substitute the value x tends to 3 minus. If we substitute, we obtain this as 3 minus 1 equals 2. Okay, now we will solve, let's just number this a. Now we will solve this one. Limit x tends to 3 plus. This means when x is greater than 3. That is, we will follow now this definition. Okay, what is the value of fx here? 3x minus 1, and we have a limit x tends to 3 plus. So if we solve this, 3 times 3 minus 7, this is 9 minus 7, this is 2. Hooray! Both the left hand limit and the right hand limit exist. Not only that, they are also equal, right? Therefore, this limit will exist. According to the definition of limit, left hand limit, right hand limit exist and they are equal. Therefore, the value will be 2. Okay. Given this expression, we have to find its limit at x tends to plus infinity. That is, x is on the positive side. Plus infinity means It's positive number like 100, 10 to the power 100. Okay. So when x is positively increasing, and here the increasing is infinitely increasing, okay, it is increasing in a very large and larger value, then what would be the limiting value of this expression? We have to determine that. So let's first write down the problem. In the expression first, cube root 2 plus 3x minus 5x square upon 1 plus 8x square. Now since x tends to plus infinity, and on top of that it is also difficult to substituting the value of infinity and determine the solution, so what we are going to do, we will play the trick. It is a very common trick, and you should remember this whenever you get this type of problem. Say x tends to plus infinity as given here, or in some cases you will find that x tends to minus infinity will be given to you. Then how you can solve this? So what we are going to do, we will take the inverse. So for in this case, if x tends to plus infinity, then 1 by x tends to 0 plus. Yeah, it means it will converge to 0 in the positive direction in the right hand side. Or if this was given to you in the problem, then 1 by x will converge to or tends to 0 minus, that is from this direction. So here if we choose x equals 1 by y, we will substitute this value because we want this expression. We want limit to be tends to 0. Then it would be easier for us to evaluate the solution. Yes, so for that reason. So if x tends to plus infinity, then y equals 1 by x tends to 0 plus. So what we are going to do, we will substitute here x equals 1 by y, and let's see what happens, how the expression transform. This is just simplification. So we will multiply both the numerator and denominator by y square, and multiplying we obtain 2y square plus 3y minus 5 by y square plus 8. So this expression transform into in this way. So now what we are going to do, we will do the same thing but with limiting value at 0 plus. This is 3, okay, it looks like something different. Now this we can write in this way, because the limit will exist, isn't it so? So now it is pretty simple. What we will do, we will just substitute 0 in the place of y, and we obtain this as cube root of minus 5 by 8. This is half cube root of, or we can put minus outside of this, because cube root of minus 5 is minus of cube root 5. So the limiting value is this one, okay, minus of half cube root of 5. Given this function, and we have to evaluate the limiting value at x tends to minus infinity and x tends to plus infinity. So first thing first, problem A, limit x tends to minus infinity of fx. This means we have to move to the left hand side direction, that is x is negative here, right? Minus infinity is in this side, plus infinity is in the positive side. So since x is negative, therefore we will take this one, right? Okay. Now it is clear that actually in this case we do not need to substitute x equals 1 by y, okay, because it is clear that if x tends to minus infinity, then definitely this will blow up, right? So we can write this in this way, and these things will definitely blow up, and x square will be a positive number, and so it will be something 5 plus infinity, it will be infinity, and in that case the limit actually does not exist in this case. Okay, next one, B, limit x tends to plus infinity fx. We have x tends to plus infinity, means x here is positive, right hand side, yes, because it is plus infinity, that is x greater than equals 0. We have to follow this definition of fx, yes, this equals plus infinity, we will substitute the value of fx, now in this case we need to do the same process as what we have did earlier, that is we will substitute x equals 1 by y, and as we have seen, if we substitute x equal 1 by y, then this becomes y tends to 0 plus 3 minus 5 by y cube, 1 plus 4 by y plus 1 by y cube. Now if we simplify this, multiplying by y cube to numerator and denominator, we obtain y cube minus 5, 3y cube minus 5, y cube plus 4y square plus 1, yes, it is simple now, yes. So what we obtain here as minus 5. Therefore the solution for this is minus 5, and here it is plus infinity, but in this case we will say that the limit does not exist. Okay, given a function in this way, piecewise continuous function, we will say, we have to determine that if the function is continuous everywhere. Now what is the definition of continuity? We will say a function is continuous at a point, let's say a, if and only if its right hand limit, its left hand limit should exist. On top of that, the value at that point should also exist. Okay, these three conditions should satisfy, I mean these three expressions should exist, plus they need to be equal. Okay, so you have to check this, that whether this is occurring here or not. So if the function is continuous everywhere or not, we have to justify it. Now it is clear that if x greater than 2, there is nothing to worry about it. It is a plain continuous function, we can see. If x strictly less than 2, then also this is continuous everywhere. So the only problem is, the problematic point is x equal to, yes, because at this point the function is breaking, yes. So we will justify at this point. Let's take limit x tends to 2 minus fx. Let's just check that what is happening here. We have limit x tends to 2 minus, value of fx is here minus x to the power 4 plus 3. Now if we substitute here, what is happening? Minus 2 to the power 4 plus 3, this gives us minus 16 plus 3 equals minus 13, yes. Similarly, let us check, this is left hand side, we will check right hand side. 2 plus fx, 2 plus value of fx is x square plus 9, yes, because x in this case is greater than 2, 2 plus means greater than 2, which is this one. Now if we substitute the value, again we obtain 4 plus 9 equals 13. Now observe that here these two things are not equal. Left hand limit, right hand limit exists, there is no question about that, the existence, there exists, it is fine, but their limiting value is not equal. This condition is not satisfying, right? Therefore the limit is even does not exist, so forget about continuity. Okay, since the limit does not exist, therefore this function is discontinuous. We will say it is discontinuous at x equal 2. A function f is defined as follows. We have to determine the continuity of fx. Is it continuous at x equal pi by 2? Fx is continuous at x equal to 0 or discontinuous, or fx is continuous over the whole real number. In one of this option, only one is correct. Okay, we have to determine which one is the correct. So this is some sort of multiple choice answer question, and as we know, this is a piecewise continuous function. Now, in order to check its continuity, we will only check at the breaking points, right? That is, at which point the definition of function is getting changed. So for example, 0 is one of the breaking point, yes, because at 0 the definition is getting changed. Pi by 2 is one of the breaking point because at pi by 2 the definition is getting changed, yes. So in order to check its continuity at 0 or pi by 2 or over the whole real number, all we have to do is we just need to check its continuity at x equal to 0 and pi by 2. Yes? Did you understand it? Because if x less than 0, the function is automatically continuous. There is nothing to check about it. If the function is in this interval, it is greater than 0 and less than pi by 2, it is automatically continuous. In this range, there is question of discontinuity is not even occurring. Similarly, if in this interval question of discontinuity is not occurring, the discontinuity is occurring, or I would say the discontinuity occurs at the breaking points. So for that reason, we are only checking at the breaking points. Okay, so let's now check at the limiting value of x at point 0. Limit x tends to 0 minus fx. When x less than 0, the value of fx is 1, and limiting value of 1 is always 1 because it is constant. X tends to 0 plus value of fx. We have 1 plus sine x. Yes, when x is greater than 0 or 0 plus, the value is 1 plus sine x. Substituting the value here, we obtain 1 plus limit x tends to 0 plus sine of x. We have 1. Now observe that the left hand limit and the right hand limit exist, and they are also equal. On top of that, we need to check one more thing. As I mentioned earlier, we have to check the left hand limit, we have to check the right hand limit, and we have to check the value at that point. Okay, so what is f of 0? We have f of 0, since here x greater than equals 0, so we will take this definition. Okay, we will not take this definition because here x is strictly less than 0. X is equal 0 in this definition. Therefore, f of 0 is 1 plus sine 0 equals 1. Hooray! Observe that the limit exists and it equals to the function value at that point. Therefore, f is continuous at x equal 0. Done. So fx continuous, b is true. Let's check another one. We have limit x tends to pi by 2 minus fx. This is x tends to pi by 2 minus, and we have the value of fx is 1 plus sine x. Okay, because here pi by 2, x is less than pi by 2. I hope you are understanding this, right? Once you understand this, it would be not difficult to solve the limit problem. Sin x tends to pi by 2, this is 1, because sin pi by 2 is 1, this is 2. Similarly, we will check the right hand limit. We obtain x tends to pi by 2 plus, that is x is greater than pi by 2. Therefore, we will follow this definition. We have x minus pi by 2 whole square plus 2. Now, if we if we evaluate this limit, we obtain this will be 0, this is 2. Now observe that the left hand limit is 2 and the right hand limit is also 2. And one more thing we have to check here, that is the value at that point, that is f of pi by 2. Yes, what is f of pi by 2? Which definition we are going to take? Yes, we will take this one. Yes, because here x is equals pi by 2. Yeah. So what is f of pi by 2? F of pi by 2 is also 2 because this is be 0. So in this case, observe that f is also continuous at x equal pi by 2. F is continuous at x equal pi by 2. Yeah, because left hand limit, right hand limit and the value at that point all are equal. So the function is continuous at x equal to 0, the function is continuous at x equal to pi by 2, and rest of the point there is no breaking. So we can say that the function is continuous over the whole real number. So this one is the correct one. Actually both A, B, D, here we have 3 answer is correct. Okay, A is also correct, B is also correct, D is also correct. Yeah, given a function fx equals with this expression, we have to determine that whether it is differentiable at x equal 1 or not. We also have to determine that whether it is continuous or not. So let me just tell you one thing, maybe it is not be related with this problem, but just for your knowledge, if a function is not continuous, then you don't even need to check its differentiability. Okay, if a function is not continuous, then it cannot be a differentiable function. Okay, on the other hand, if a function is continuous, then it may or may not be differentiable. Okay, if a function is differentiable, then it is continuous. Okay, if a function is continuous, then it may or may not be differentiable. Okay, remember these two things, it will be easier for you to solve the problem, because sometimes, just for this example, if you can show that a function is not even continuous, then showing the differentiability is not even occurring. Yes, so let's solve this problem. We have to show that this function is continuous and differentiable at x equals 1. So first we will show its continuity. How to show the continuity? We will check the left hand limit, we will check the right hand limit, and we will check the value. Okay, these three things should be equal. Now what is this one? Limit x tends to 1 minus fx. Since 1 minus, that is less than 1, therefore we will take this definition. So if we simplify, substituting the value of fx, we obtain here 2. Yes, what we are obtaining from here, it is 2x, x tends to 1 plus, that is x greater than 1. This is also 2. And what is of f of 1? Which one? Not this one, right? This one, because here x is equals 1. 1 plus 1 equals 2. So these three things are equal. Yes, therefore it is continuous at x equal 1. Therefore f is continuous at x equals 1. Okay, now we will check its differentiability. How to check differentiability? We have to check this thing. We have to check this two things, whether this two expression or these two limits exist, and this should be equal. Okay, this should be equal. These two limits should exist and these two limits should be equal. Only then we can say f is differentiable at x equal 1. Okay, so first let determine this one. So we have limit x tends to 1 minus, we have fx equals x tends to 1 minus means x square plus 1, and we know f1 is 2, yes, minus 2 upon x minus 1. This equals, let me just give an arrow so that you can understand here. This equals x square plus 1 minus 2 minus 1. Limit is also there by x minus 1. Limit x tends to 1 minus this limit x tends to 1 minus. Now if we simplify this, x minus 1, since x is not equal to 1, therefore we can cancel out this using the formula x minus 1 x plus 1 upon x minus 1. Now since x is not equal to 1, we can cancel out this, and finally we obtain x plus 1. Substituting the limiting value, we obtain 2. Yes, so in this case we obtain the left hand limit or this expression as 2. Now we have to check this one. X tends to 1 plus fx. Since x tends to 1 plus, we will take this value. This is 2x minus f of 1. F of 1 is 2 x minus 1 we have x minus 1 upon x minus 1. Same formula, x minus 1 will get cancelled out because those are not exactly equal to 1. Those are limiting value. It is close to 1 but not 1, right? Therefore we can cancel out this. Simplifying, we obtain 2. Now observe that left hand limit, right hand limit exist and they are equal. So according to the definition of differentiability, limit exists, they are equal. Therefore f is differentiable at x equal 1. Okay, so in this case we obtain that f is continuous and differentiable at x equals 1, but not for all example this happen. Okay, as I mentioned that not always this thing happen. So this problem has given, we have to show that this function is continuous but not differentiable at this value. So let's start the same process. You should also try this. Okay, try this by yourself, pause the video, try this by yourself and come back and check. First we will verify the continuity. Fx is here, x 1 minus tends to 1 minus, x less than 1, x square plus 2. Yeah, pretty simple. 1 plus 2, 3, tends to 1 plus, fx 1 plus, that is greater than 1, x plus 2, 3, and f1. What is f of 1? We will follow this definition, x less than equal 1, therefore x square plus 2, 3, c. Left hand limit, right hand limit and the value all are exists and equal. Therefore f is continuous at x equal 1. Now we have to show that f is not differentiable at x equal 1. And for that what we have to do? We have to check. Same method. Very simple indeed. Yeah, you have to check this two limit, that whether this two limit exist and they should be equal. First check the left hand one. We have x tends to 1 minus fx. When x is less than 1, fx is x square plus 2. f1, we know f1 is 3 and denominator is x minus 1. If we simplify this, x square plus 2 minus 3 means x square minus 1 by x minus 1. Simplifying, we have x plus 1. This is 2. Okay, now I am using different color. We will check this one. Okay, we have very little space here, but I will try to manage. We have fx, x tends to 1 plus, that is x greater than 1. Therefore, it is x plus 2 minus f1 is 3, x minus 1. If we simplify this, what is happening? We are obtaining x plus 2 minus 3, x minus 1, and x minus 1, it will get cancelled out, and we obtain the answer as 1. Alas, check that. We have our left hand limit is 2, but our right hand limit is 1. Even though the limit exists, they are not equal. Therefore, the function is not differentiable at x equal 1. So we can conclude here that f is not differentiable at x equal 1. Okay. If you have any doubts, let me know in the comment box. Okay. Maybe I will make a separate video.